So first of all, when I look at this image, right? So as a human, I can recognize this as Abraham Lincoln. But how do machines actually? So when we talk about models like Dolly, and we talk about stable diffusion models and Midjourney and all of that, how do computers work? So computers work on numbers, right? So whether you're giving them, well, numbers, actually numbers, or you give them some piece of text or some images, some pixel values, really anything. This is what humans see. And on the other end of the spectrum, when this image goes to a machine sees this. So basically, what all of us need to understand, for those of you who are absolute beginners in machine learning, the idea is that anything that is given to you, whether it is an image or a table, some text, all of that has to be converted into some numeric representation. And in that case, text is no different, right? So imagine I have some magical way of mapping my documents, or maybe all the words, right? So this is a truck, and the truck is located on this X and Y or horizontal vertical coordinate system. It is located at 6 and 1. Bicycle is at 5 and 1. There is these cherries and bananas and strawberries. All of them, they are located at different places. And there is some mechanism that takes these words and maps them into some, in this case, in a plane. And when we talk about huge documents, it is a very high dimensional space, right? So you think of this as extending it to 3 or 4 or maybe even 1,000 dimensions. So when you hear about this, that your embeddings are in, like this is an embedding in 2 dimensions, but when you talk about embeddings in a higher dimension, sometimes you'll see 4,000 plus dimensions, right? So each piece of text is mapped like this. Okay, so let's actually continue with this example. For instance, right, so if there is an apple and a soccer ball and a house and a car, there is some mapping mechanism that actually takes each of these words and it maps them to the concepts that are closer to the meaning that these concepts communicate, right? So the apple is a fruit, right? So it is close by related to a fruit, versus a soccer ball versus a house. It's a building, and this is a vehicle, or right? You map them according to the semantic understanding and meaning. So embeddings actually are what embeddings do is, imagine I have millions and millions of documents that I've processed, right? And I know certain words, they appear close to each other in the context of, for instance here, right? So a man wearing a life vest is sitting in a canoe, right? So, and semantically, when you have seen a boat and a canoe multiple times, there are actually techniques that actually can figure out that canoe and boat are usually used, they're often used in a similar context. Let's actually put them together. So semantically, they're similar. So this is a great example in this case of, if you look at these 2 sentences, if I asked you, are they similar in a lexical context? Lexical meaning, are the words the same? Well, we are talking about a guy here. We are talking about a man, and then this guy is wearing a red jacket. So there is a red jacket in the first sentence. There is there's a life vest. This person is standing. The guy is standing. The man is sitting. The guy is on a boat, and the man is in a canoe. So if you look at this, it may not be obvious with just 2 sentences, but if we extend it to perhaps millions and hundreds of millions of documents, then patterns start to emerge. Okay, let's continue here. So what is a vector database then? Well, when we create these embeddings, we are not talking about a man and a guy, or maybe apple and a soccer ball and a car and a house. We are actually talking about hundreds of millions of embeddings here, right? So